All right. Well, up next, as a reward for staying awake so far, we're going to YouTube. And we're studying hydraulics and hydraulic presses. All right, carbon fiber tube lateral. Carbon fiber tube vertical. All right. All right. Thank you, YouTube, for that little break in the action. So let's talk about some of the innovations, and I put innovations up there tongue-in-cheek because if we were talking about iPhones, we'd be talking about a 2 or 3 month innovation cycle. This is closer to 3 or 4 years is the innovation cycle on hydraulic oils at best. So we're going to talk about 4 different categories, or 4 different things that maybe it's trends, things you may have seen, things that may still be coming, and a few things you might need to know about it or how they tie in with what we've already learned about hydraulic oils. We'll talk about multigrade hydraulic oils a little bit more. We're going to talk about high efficiency hydraulic oils, or HE. If you've ever seen a hydraulic oil with this suffix on the end, that's what that's about, and we'll explain that. We'll talk about highly filtered, ultra clean hydraulic oils and why that's been a growing trend. And we'll talk a little bit more and get a little more detail on what it is with these biodegradable hydraulic oils. Because we get a number of calls from people who are, for instance, doing projects for a municipality where the requirement is that all your machinery have biodegradable hydraulic fluids in them in case there's a spill. All right. So let's start by talking about multigrade hydraulic oils. Multigrade hydraulic oils actually have been around for quite some time. In some better iterations than others, and the quality of these things does keep getting better. But you can imagine they're used for winter and outdoor use. Again, where fluctuations in temperature are real common. Snorkel and lift trucks and cherry pickers. Okay, as you can imagine, on the long end of a cylinder up here is not getting much ambient heat from the engine to change the viscosity or to keep the viscosity down. So with a long throw and a lot of volume like that, you don't want your viscosity changing too much in the operation. And of course, aviation, where your hydraulic systems have to work both at an ambient temperature on the ground as well as the temperatures at 30,000 feet in the air. So multigrades are important for that. Okay. Again, the multigrade type hydraulic oils require our special viscosity modifier additives. Right? You remember that? These guys that go out there. And again, the key difference here with hydraulic systems, these guys have to be shear resistant. They got to be able to avoid getting chopped up by the pump. Unlike we said, that's what happens when you put in 1540 or any typical engine oil. Those are a relatively inexpensive kind of viscosity modifier. You got to buy the good stuff in order to continue to keep the multigrade properties of your hydraulic oil. Okay, so multigrade hydraulic oils, they use special or different viscosity modifier additives that avoid that. All right, so these are becoming more and more popular in In the Phoenix area, we don't experience the temperatures, quite the temperature swings that some other places do, especially in terms of the low temperature situation. But these are important. Now, their close cousin are the high efficiency hydraulic fluids. And this is I suppose is something as close as we got to a new innovation anymore. High efficiency hydraulic fluids, HE fluids, are also multigrades. They start out multigrade, and they have that same type of additive in there, yet it's an even more special version of that additive, okay? In our hydraulic, the basic hydraulic system that we drew, you could see the thing was a continuous loop from one way or another, right? Hydraulic systems, especially once they start to wear, begin to experience what's called internal leakage, okay? You're pumping hydraulic fluid. It's under very high pressure. It's throughout that system, and of course a high pressure fluid is going to try to squeeze through any possible thing that it can. And it will, if you have some wear, like we had that piston up here, if you have some wear between that piston and the cylinder, some liquid's going to leak through. All right. Well, the more complex systems you get and the bigger systems you get, the more leakage you can get. Now, the leakage may not result in an operating problem, but you're having to and it's not a leakage that's ending up on the ground, right? It's not an external leak; it's an internal leak. Okay. Well, these additives are such that they reduce the internal leakage. Okay. They reduce the oil that's having to make its way through the system and go back to the reservoir and get pumped again due to internal leakage. And this is surprisingly more common, has more of an effect than a lot of people think. Okay, they offer what these additives are offering, what these HE fluids are offering, I guess, it starts with the additive, is energy savings or fuel savings. Okay, depending on where you're looking at it. The people in the plastic extrusion and injection molding industries are very excited about this on the industrial side. Earth-moving people are looking at it on the yellow metal side of things. How much improvement? Well, somewhere in this 5 to 8% efficiency is kind of the number that's out there. The HE product we sell from Phillips 66 claims 6% efficiency improvement. The HE product we sell from Chevron, their data sheet says lab tests show 8% efficiency. The additive manufacturer, who's kind of the leader, who we stole these graphs from, a company called Evonik, claim anywhere from 8 to 10%, and they have field tests done, I think it was in D9 bulldozers, field tests showing up to 30% savings. Okay, so there are efficiencies to be gained. How much? Well, your experience might vary. Okay, but that's one of the bigger things in innovation these days, these high efficiency hydraulic fluids. The third innovation is something, if you attended our session on clean fluids last spring, you might be familiar with or have some idea of. And that is the ultra clean hydraulic fluids. Very clean, highly polished, highly filtered hydraulic fluids. So I'm going to take you back again to that clean fluids presentation and talk to you about what a particle count is, because we're going to mention particle count. I could spend 2 days explaining particle count to you and you wouldn't understand it anyway, so I won't get into the gory details. But particles are counted in a sample in a device like this, where you've got a small sample going down this clear tube and you're shining a light through it and it's making a shadow, and you got an electronic counter that's counting the shadows. Tells you, okay, how many particles are in that milliliter of oil. Sometimes they use a laser instead of a light bulb, but that's how you do the particle count. You're just literally counting the particles, how many particles are in a milliliter. Okay? And the way you run the official test is you run like 3 different benches. You measure stuff that's greater than 4 microns in your sample. And 4 microns is really, really tiny. That's only a couple times bigger than bacteria, right? Greater than 6 microns, and then that greater than 14 microns. And if you measure these different dirtiness levels, this will give you some kind of like a profile of the dirt that's in your system. Not just how much, but where the bigger proportions are. Okay? And this all gets reported as the ISO particle count. And so the way this would work, let's say we set up and had the 4 micron filter going through there, and we counted 5,400 particles in our milliliter. Okay, 5,400 particles at 4 microns. Well, then we go to the chart. 5,400 is in between 5,000 and 10,000, so that's a class 20. So it gets assigned the number 20. So our 4 micron particle count is a 20. Okay, and it gets reported as this three-digit number. What's at 4 microns, what's at 6 microns, and what's at 14 microns. So what we just measured, that 5,400, the first number would be 20. And we do the same thing for this number, and so you end up with a number that's 20, 18, 16, or something like that. And I've got something like that. Typical new oil from a drum comes out at this amount of dirtiness. That's 21, 19, 16 from a new drum. Okay. Now you will look at this, and to the visible eye, you can't see a particle. In fact, you can only see down to maybe 40 microns. So you're not going to be able to tell that this doesn't look anything other than great. But it does have small particles in it. A typical OEM hydraulic pump manufacturer recommends cleanliness levels at 18, 16, 13. Okay, that's considerably cleaner. We're only 3 digits away, right? But that 3 digits is 3 times. 3 times as many particles here than there are here. Okay, that's a big leap. So that's a typical OEM recommendation. With ultrafiltration, some sort of a filtered delivered product, you can get down to numbers like this, a 14, 12, 9. I mean, magnitudes cleaner. This has 4 times fewer particles than that does. Okay, very, very clean stuff. All right. Okay. So, why is being clean all that important? Well, it has a lot to do with valves, control valves, valve bodies, and what goes on inside. And a couple of mechanisms going on in there, because they are very susceptible to dirt. They have very, very tight tolerances. These things are machined very, very, very tiny bits. And among other things, you can get what's called silt lock, where if you get particles can build up in these spaces and cause these little spool valves to not be able to move, or to not be able to move very effectively. You can't get them to do what you want. And a hydraulic system may have a number of these things, and they all require that they all be moving perfectly smooth and even, and the flow go well. In addition, if you've got a bunch of particles in here, remember this is all fluid moving fast and under high pressure, that fluid acts like a sandblasting agent as it's going through here. And it wears away at the corners of these sharp edges, which doesn't seem like a problem until you realize that these have to move just a very little bit, and the movements that they're allowed are very tiny for stopping flow and making it. So now your system's not going to behave like you expect it to behave because of the wear in your valve body. So between wear and silt lock, valve bodies are very sensitive to particles. Okay? So we want to prevent wear of the valves and valve bodies. All right? So that's why that's important, and the cleanliness can result in great improvements in component life. That's the kind of the bottom line. Just getting these a little bit cleaner can double the life of your components, including valve bodies, but also pumps, and even in some cases, hydraulic hose and other components. And I will give you an idea of hydraulic life extension on how that works. Okay, this is a life extension table. And the way this works is you take a look at the product that you're currently at. So it came out of a drum, we said, at 21/19/16. All right? Let's say we filter it down, get you ultra-filtered stuff, that's at 14/12/9. Okay, so this number 7 means your likelihood of components lasting is a 7 times longer life, which almost seems ridiculous until you take a look at those actual numbers and the particles and the particle count and realize how much cleaner that is. Okay? If you want to take a look at this company called Noria. Noria is a lubrication-related reliability consultancy and research firm. Does a lot of training and had started doing research on this kind of stuff, I think back in maybe in the 50s or 60s. They've been paying attention to this stuff for a long time, and they have a number of these kind of charts set up for systems, but hydraulic systems particularly valuable to find out that it doesn't take, you could take that 21/19/16, you filter it just down to where the OEM wants it and get double your component life. You know, pretty powerful stuff. All right, so that's the key benefit and the takeaway of ultra-filtered, highly filtered hydraulic oils. And then the fourth trend/innovation thing I want to talk about is biodegradable hydraulic fluid. Okay, see here in Tempe Town Lake, we were involved, when they built this lake, we were involved in specifying and providing the biodegradable hydraulic oil that's used in these hydraulic rams here. Okay, and of course they want it to be biodegradable because if any of these leak, they don't want to have to mess with the pristine Salt River riverbed. Okay, so what does it mean to be biodegradable? Well, there are a couple of classifications that hydraulic oils use, or that are mentioned in terms of hydraulic oils. The first is readily biodegradable. Okay, readily biodegradable. You run this very specific biodegradation test. You inoculate it with some stuff, and you see, and you let it go for 28 days, and you see how much of it's gone. Okay, if it's mostly gone in 28 days, it's readily biodegradable. Okay. The next classification is inherently biodegradable, and that means it'll biodegrade, but it took longer in that test than the 28 days. Okay? So those are the that's what biodegradable. So if someone comes to you with a biodegradable hydraulic oil, you might want to know whether it's inherently biodegradable or readily biodegradable. And its biodegradability is going to depend on a couple of things, on the base oil and the additives. Okay? So let's talk about the base oils. It's going to depend on your base oil type. A mineral type base oil. Okay, we dug it out of the ground, cleaned it up. Mineral base oils are usually inherently biodegradable. So they will degrade, but in that test they just won't be mostly done in 28 days. They'll take somewhat longer. All right. Synthetic based, the answer there is better, is more like it depends. Okay? Some synthetics are much more like the base oil. They inherently, but they will biodegrade. Some of them are more readily biodegradable. Like, so the one in Tempe Town Lake is a readily biodegradable synthetic. And then the vegetable-based hydraulic oils that are biodegradable, I've never seen one that wasn't considered readily biodegradable. All right, so most of the stuff does depend on the base oil, because the additives, the additives would make a difference, and the key here is that an additive to be biodegradable can't have zinc in it. Okay? Zinc doesn't biodegrade is the rule, right? So you can't use a regular zinc-based anti-wear oil in a biodegradable hydraulic oil system. It will not biodegrade. But there are non-zinc anti-wears, and that's what gets used. Again, it drives up the cost, but that's what gets used. Our other additives, our anti-foam and our rust and oxidation inhibitors, those are all biodegradable. So they're all fine. Okay. All right, any questions about these 4 hydraulic oil trends? Okay. All right. Well, thank you very much.